So, okay, I started with Scots. So, all right, my advice on how to start this for you guys is do your best to find this object online and see if you can get more photos of it. That will help you. As part of Project 3, though, I hope you guys are fully aware of this. I think you guys are. But I've said it before, you have to render this to match the rendering that you have picked. So the exact piece of paper you have, that's what you're trying to match. And that's what I'm grading you guys towards, okay? Um, Now, in an ideal world, you would be able to find this image and find like a side view orthographic of it. Probably not going to happen, but if you can, I would start it the exact same way you started the bottle. You have that side view, you drop it in as a reference picture, and you actually trace it. If that doesn't work, you can totally drop in, I think I did it on my file. Let me open up the original. No, this is the wrong one. Yeah, you can literally drop in the exact picture reference. And even if it's not, whoops, let me do that. Yeah, there you go. See, like this picture was not an orthographic, but because I know it's a revolve, I was still able to get the rough angle of it. And I was able to get the rough height of this. So like with Scott's here, this, let's see, I think I have this photo on my desktop. Like here you go, there's a back view, so you can get the width. But you could totally start, I mean, actually, I should practice what I preach and just bring this in. Really, I should also time myself because I will totally end up spending too much time on one thing. So I could here make a sketch on the front plane, import an image. In this instance, this is what I want. And at the very least, what this is going to do for me is it'll give me the overall height. I'm making some judgment calls, like just observationally. So meaning to say, like, I don't know, I'm assuming this is about 6 inches tall from like this point to this point. And that's okay. Like the scale, just do your best to guess. You know, like you see how it juts down here because of perspective. I'm just going to align that here like this. You know what, that's pretty good. I'm going to leave that here. I also like to, again, change the transparency, select full image, knock it to about whatever that is, 66%. And now if I rearrange my sketches so that my master sketch is below, you know, maybe 4 inches is a little wide. Maybe it's like 3.75. But now I can start to try and get like what this equals to, this angle here. You know, maybe this needs to poke out a little bit further. And so now the way that I've built this, I've started with a revolve of like the speaker area. You'll notice that like some weird things happen, right? Because it's revolving at this angle from here, we get a point on the back. And again, in fact, I would actually recommend that you build everything in halves. So in this instance, if it's a blind revolve, I would dial it into 180 degrees. Then my gut was to say like, okay, if I extrude this, what does this look like? And you can see like, there is nothing smooth about this, right? Now part of that is, okay, how wide should this go? So in your master sketch, let's see, how would I approach this? I would probably go to my master sketch. Honestly, I want this to be parallel to this because I want the edge to be flat, even though it doesn't quite align well here. I can adjust this later. It looks pretty close. I can maybe move this up so it's a little bit in between. And again, it's not a true side view. And here's oh, sorry. While I'm in my master sketch, the other thing I want to check is what this distance is. Let's call this an even 3.15. That gives me the diameter of this revolve. That means then that if I extrude this, again, I'm building half of it by 3.15, it should align tangentially to here, but it's not. Oh, it is, okay. There we go. So now we have this smoothness through here. But of course, we notice there's this gap here. The way that I would fix that, sometimes in SOLIDWORKS, it's always easier to cut than it is, not sometimes. It is generally easier to remove than to add bodies. Because by removing, we can remove exactly what we want and have it be smooth. So here's an instance where I'm going to deviate from my master sketch. Remember, like I said, the goal of the master sketch is that everything is still pointing to it. By moving these lines way out and making this, I accidentally made this, oh no, I didn't. By making this perpendicular here, I now get a really nice long blend. But now, I'm going to, for a minute, I'm not going to merge this result. I'm going to uncheck that. Or no, let me rethink this. Sorry, we can leave that merge. What I want to do is I just wanted a flat cut on the back here, not from the revolve. So on this front view, I'm going to pull this line from my master. And again, I'm trying to avoid that point that I got. Hopefully you guys all saw that. I'm going to extrude cut this. I'm extrude cutting just a line. I'm making the setting to be through all. I'm going to flip the side to cut and remove all this extra stuff from the back. And now if I go down to this extrude, now we have a nice blend that's starting to look a little bit more of what we're going for. Does that make sense? Cool. No, that's great. If I'm looking at the details of this, honestly, like if this is just like the starting point, really the nuance is, it looks to me like the back actually kicks slightly here like this. So in reality, like this cut here, I may have, if you want to be a little bit more accurate, would probably pull this part of the sketch, trim this here. And now we have this like slight kick in the back. So, okay, here's where it does get a little bit trickier now, however. Well, firstly, my proportion looks a little off to me. It looks like it should be taller. Here's again where it helps to have this sketch in here. And now here's what I'm noticing, right? Look at, this represents the center line. And like, look where it's meeting. It's like way below the center. So here, like I might define this height overall. Take that away because I don't want it to move up. I just want to move just this so that this looks like it's a little bit more centered here in the center of that disc on the back. Move this down. But of course now this changed, so I'm going to have to change the extent of my extrusion here. So let's change this to 2.3 even. So now my extrusion needs to go to 2.3. Let's see, what's a more clever way to do that? I could do this. Instead of always having to constantly tweak that number so that they match, I can change this instead of blind to go up to vertex, and I can select this. And now no matter what that changes, if I go back to my master sketch here, and let's say I change this to 2.4, it still aligns tangentially there because I picked a point on there. Does that make sense? Yeah. Okay. Okay, now the hard part of this really is what happens in this blend in here. I don't know. I mean, really the simple solution would be to do something like this. Let's see, and to run a fillet along this way. Honestly though, it's probably better. Like honestly, this fillet, could maybe benefit from being, what's it called, a face fillet with an even contour. You know what, for this project, I think that's okay. This will get you close. The key in here though, that I would do a variable fillet because it looks like it's really a big soft into a tighter fillet here. So a variable fillet is you pick a line and then you pick two different values. Right, yeah. Now, I'll be honest, I don't love this. Really the best way to do this would be with a surface loft. Because you get this weird point here, is mainly why. And then like this transition is going to look funny. I mean, you might, oh yeah, don't do that. Look how it cuts in, that's terrible. Don't do that. You may be able to get away with like a, let's see what just like a really small fillet in here looks like. That's still not quite what I'm seeing in this file here. I wouldn't. You could, okay, you could maybe try and align this and this a little bit better. You see how offset those are? That might help. So if that's maybe what you meant, that's one way about this. So let's see if we can, let's see, we have too many constraints here. It's not doing what we want it to do. Honestly, I feel like this is the culprit. Yeah, there we go. Let's see. I think if we put a reference line here and make it perpendicular to this and for construction, we can kind of align this with this gap, and I think that should align it a little bit. Let's see what this looks like. Yeah, this is aligning them a little bit closer by doing that, but now the proportion's like way changing, unfortunately. And again, I am grading you guys on accuracy of how closely you can replicate this. Let's see that. The fact that I want this to be parallel to this is somewhat constraining too. It's not ideal. So okay, let's look at this. How might we do this with a loft? You could use this. Okay, so I'm going to pull this line here, and I'm going to split this. So before we were using splits to create windows and stuff. This is honestly a more proper way to use a split, is to say like, okay, I have my bodies. Now I just literally want to work on just this part of the body. You might, if I'm looking at this, while we do want fillets as low as we can get them, in this instance, again, looking at this, at the image, we have a small fillet on this edge that runs around the bottom. And essentially, we want to loft this body to this part of the cone. We could, let me try this. I'm using this just as a reference here to cut something. You know what, actually, let's leave this. Right, this is kind of rough, but I'm just going to go for it. I'm using this kind of like U shape to cut out this intersection between the two of them, and I want to keep both bodies. So I'm going to click OK. The reason that I put this fillet in here is so that we don't have a corner. It's nice and soft through here. So these fillets are a little bit higher than I'd like, but I could, in theory, I could now try lofting this face to this face, right? Now the key, though, in this loft, well, firstly, we probably need some more guide curves in here. So, but this is where we could use this other body. I now kind of have a built-in guide curve right here. You would probably want, you can see like how it's a bit still wonky here. Let's try this. If this does anything for us. This is where you might want to use, well, for sure, let's see this front face. we can get a sketch going. This is an instance where I for sure would use, where I think it's acceptable to use a spline. Because I want to go from here to here, and I want this to be tangent to both. And I want it to be as soft a curve as I can get. And I don't know how many like arcs that would take, right? This is kind of an obscure shape. This is also where you may want to use a 3D sketch, okay? So let's start, before we get there though, let's look at this. Let's just see where we've gotten with our guide curves here. We can use this as a guide curve. You can see this is already looking smooth. We can use this as a guide curve. And actually, we may not need a 3D sketch at this point. That's looking actually pretty good. We want to look at what we're merging. Are we merging the result? And if so, to what? I think we can merge to both. That's fine. Yeah, it's not perfect. But no, it's better than what we had before. We can now see kind of like what a fillet through here is going to do. There's kind of some weird things going on because it's on the right path. I think it's better than the fillet that we did earlier. But what's weird is that this is a bend. This is a concave bend, whereas this is a convex bend. Meaning to say that this goes in, this goes out, and filleting along that edge is tricky. We could try and add tangency to this loft. But I was going to say, I don't think this is going to go through. This is, again, where in theory, this would be better to do as a surface loft, essentially, which yeah, but it's totally doable. I'm just thinking about how much time I have to get into each of these things. Like, say that again, sorry. You could. I mean, it's pretty complex. It's more. I would at least rather speak towards it. So let's see here. Let me look at this. I mean, my hope with these exercises was to give you guys an approach and have you guys then fine tune it. I mean, I really think this is along the right path. I think you just want to tune in this loft. I think you could get away with it with fillets though, like we did the first time. And again, for this class, like here, this is the other approach, is maybe, let's see, let me blend all this back together. And again, here's where you could use, for example, so okay, think about the orientation of the fillets. Here I put this fillet on here first. So now this is going to give us a more consistent blend throughout all of here. This may be an instance where you want to use a face fillet and keep this chord width symmetric and see how big you can maybe get this. This may be like an acceptable workaround for this class. Again, without getting into, honestly, that's probably what I would do. You see it? Yeah, this is, I think, okay, in a perfect world, and when we had more time, I would totally get into surfacing. It's going to be too much for me to dive in and touch with everything here. If you want to look at what my tree is here, let me just sum up for you, Scott, I think some of the key things. One is I would set up your master sketch something roughly like this. I think it's key that this part of your cone is parallel to your revolved center line, because that's how you're going to get a smooth blend on the outside. Essentially, your object is constructed by a revolve and an extrude. I think the key to getting this to be smooth is the order in which you have your fillets. In this case, I filleted this edge here. I filleted this corner here so that I now have this clean line that runs all the way throughout. And now if I throw a face fillet on there with an even chord width, I get a pretty even, smooth blend throughout here. It's not ideal, but it is an acceptable workaround, and it will get you a rendering that will look pretty close to what you have here. Right. Yeah. Short answer, yes. Let me give you a longer answer. So let's look at this. Project 3. Um, yeah. So, okay, the complete project, obviously you have the SolidWorks model, but there's two. There's the replica and the redesign. You will have the original render from the internet. So each of you either need to find this. So if this was not the image you brought in, try and reach out to the person who has it. If any of these are my images, I will throw them on Box. 2 of you have my images. 3 of you have my images. I will throw them on Box so you have them. Try and figure out who brought in the original image and see if you can get it from that person. Your question was, the Keyshot needs to match the render and the SolidWorks needs to match the form. The short answer is yes. The long answer is I'm more concerned about the Keyshot render matching and the overall look. But if we look at the grading here, okay, so 5 points for CAD models. So I'm looking again for all the same stuff: efficient builds, no errors, tree organization, and yeah, replica accuracy. So how close does it look? Then 5 points for design details. This is more for the redesign. So like, again, from the last project, thinking about how you spaced everything. Making sure there's enough room, so things don't feel too cramped. Where do you put the part lines? We talked a little bit about realism last time in part lines, how it should be the widest part of the object for moldability. And again, I can help you guys with that as we, in the next class. Again, the homework is to have this built for next class. Next class, I'm going to talk with you guys. We're going to do Keyshot again and try and match the render. But then I can also talk on like how you might change this, right? Again, think about like the touch points, the chords, right? You can do a chord with a sweep. I'll upload my file to Box here so you guys can see how I built it. I guess you guys already have it from the exercise. You can see how I built that. And then 5 points for the Keyshot rendering. How closely does the replica match the original? And that's literally, I'm looking at both and I'm seeing how many differences there are. And you want to get that as like absolute close as you can get it, yeah. And then of course like logo, labels, and lighting in the redesign. Does that answer your question? Awesome, that's great. It's very similar, yeah. Okay, cool. Any other questions, Scott, on your model? Okay. Do this. So Ned picked this drill. Good choice. Also going to be a little tricky, but you got this. I have faith. Awesome. You have lots of reference. That's good. Okay. So again, let's see. If I'm looking at this as a drill, I'm starting with, I would probably put the origin right in the center of the barrel of the main shaft. So I'm going to, yeah, thanks, Scott. So I'm going to make this coincident. So this represents the main shaft of the drill. This represents the handle. I know, like, just guessing on size here. So I want these two lines to be symmetrical to each other, about the center point. That shaft of that drill is probably 2 inches, maybe. Let's just call it 2 inches to start with. But the reason that I want this up and down measurement, and I'm also going to swap my options, my units to 2 inches. is so that I can get kind of my handle length. Which here, this line will tell me where my handle ends. I'm going to make this coincident to the midpoint. I'm going to make this perpendicular. I want a point on the bottom of the shaft here. And I know I want this to maybe be about 4 inches at least. Let's go 5, because that's looking a little short. But anyway, this is just my starting point. And again, I'm using rough. If you guys are confused as to like how to start with dimensions, you can find a similar object in real life and try and mimic that. But if any of your objects have a handle, you can assume that that roughly means that that handle is about at least 4 inches long, I would imagine. Okay, so the reason I started with that is so I have at least a reference in proportion. I'm going to create a new sketch on the front plane now, and I'm going to import this image. Thankfully, for Ned, this is a side view. So now you have something you can literally trace, which is actually really nice. So again, here I can kind of check my proportion. Let's see, this goes all the way to the bottom. I think that's pretty good. Let's see, maybe the handle is a little stubby. Let's make this a little bit smaller. And like maybe I do want to align this like right in the middle on that part line. And then so from here I would change this transparency to like, again, just knock this way down so it's not too distracting. After I exit that sketch, I can now rearrange them. I can drag my master sketch below, and now when I edit my master sketch here, I can make some adjustments to match this. So get this to be a little bit taller. You know what? That means I need to scooch my master sketch down a bit, or my reference sketch down a bit. That's pretty good. It doesn't have to be exact. But now I have this angle. I can pull this angle here. I can shorten this up a bit. And now let's say I want this relationship, this angle to stay fixed, because it is. It's not going to change. I can just throw in a quick dimension here. It looks like it's really close to 70, so I'm just going to round it to say, okay, no, that took it way off. Let's make it 69, see what that does for us. There you go. Closer to 69. So now you could literally kind of like trace this out. And again, this is all very similar to what you did before with like kind of the bottle. You want this to be tangent. Here you probably want this to end here. You can trim this shorter. So again, you know, being the file you picked, you want this render to be as accurate as possible. You'll notice there's a drill bit in here. You're going to want to, the best thing you can do is just download a CAD drill bit, so you don't have to rebuild it. If you want, I can show you how to do that. You can do it with a helix command. Actually, this is useful to all of you guys right now. I'm going to show you if you're not familiar with this. Grabcad.com. Maybe you guys are familiar with it? Okay. Okay. So yeah, you do have to make an account and join it. I encourage it. It's useful. But like I can literally type in drill bit, and here you go. And you could just like grab this. You want to check though. It should tell you what the files are. So for example, this one says Autodesk Inventor. It's like that may not work. Hopefully, it gives you an extension. Yeah, ideally, I wonder, can you filter? Yeah, here you go. You can filter for SOLIDWORKS. It doesn't have to be SOLIDWORKS though. Like honestly, STL, SOLIDWORKS can open. It's like step, yes, step is universal. Yeah, here you go. SOLIDWORKS STL rendering. So here you go. You could download this drill bit, and that's probably gonna be good enough. So if you guys have any common elements in your object, you can use GrabCAD. That's totally fine. And in fact, we're going to use GrabCAD a little bit for Project 4. Okay. I'm going to continue with this. Is this all making sense? And not so far, right? Nothing crazy, right? Okay. So that's roughly what the master sketch looks like. I think it would be best to have a plane down here to represent your handle. So again, guys, to create a plane, you go to Insert, Reference Geometry, Plane. In this instance, I typically like to create planes with 2 reference points. One a sketch, and then a point on that sketch. Or sorry, I take that back. A line and a point on that line. Or I guess it could be a curve. But basically, like what this does is it makes the plane perpendicular to that line. So in this instance, this is our center line of our object, but now this becomes the base point of this handle. All right, so we can make a couple assumptions. One, we're making the assumption that this drill is round, the main body. But if I look at the handle here, especially if I get this, oops, I'm building this from the front view. You guys notice this line, specifically in it? How it curves and then it goes straight and then it curves again? It's like a slot shape. Right. So it's helpful to make some of these observations. It's going to help your rendering, your lighting look more realistic. Again, the more accurate your model is. So on this handle shape, what I'm going to do, and actually wait, I'm doing myself a disservice. In my master sketch, it's going to be helpful for this bottom length to be the exact width of that handle. Because now when I do a sketch on this plane, I can just grab this line. So even though like we have all this mess of lines here, I know this is exactly how long my handle needs to be. And so again, this is where I might use this slot tool. Make both of these points coincident. And then again, this is where it's helpful to have some general knowledge of like product dimensions. So this handle is probably, I would say, at least 1 inch wide. Let's call it 1.5 inches. Maybe at least is. That's a very long handle, though. Okay, so I maybe need to revisit my proportions here. So okay, to let you guys into my head what I'm thinking, we match this trace front to back, but this is a dimension I did not pull. It helps to just double check yourself. I don't see a ruler lying around in here anywhere. Oh, great, thanks, Alexis. So like, think about it. Oh my God, 2.4 inches, like that's a really deep handle, right, for a drill. Like, think about grabbing a handle. That's not very comfortable. So, a couple things. One, you can just kind of tweak it overall. Like, man, I wouldn't make that bigger than 2 inches. Say again? Yeah, that's true, I guess. I still think, yeah, I guess you're right. Right. Again, you could go to like Home Depot, look at a drill, I don't know, get a measurement there. So fine, let's pick a middle ground. Let's say like, man, I still feel like 2 inches is big, but let's just go to 2.2. That's still pretty close, I guess. We can kind of slide this back a bit. All right, that's cool. I'll buy that. And then maybe that tweaks then how wide you want to make this. You know, I guess 1.25 inches. That makes sense. All right. So this, now this is at this point, it's like this could be a new master sketch for the handle shape, or it doesn't have to be. It's up to you. because it is a slot, I will leave it as a master sketch for the handle. So I'm going to make a new sketch on here, and I'm going to copy this over, and that's so that I can now trim this. And again, I encourage that you build this in halves. So this is what I'm going to extrude. Why am I not? And I want to extrude this, again, here I can say like, hey, I want it to go all the way up to this point here or something. Or no, I guess here's my origin. I can have it go back to the origin. And now same thing here from the right view. I could, like I said, we're making an assumption that this is a circle. Because we know it's exactly in the middle. So if you want like to have an intersection of like a circle and a line, you need a point on there. So I can drop a sketch a point onto this circle, make it intersect with this line. Or I could have, I guess, have known I was going to draw this line through here. So you can see that this circle now aligns with this top and bottom that we have defined. I can extrude this again up to vertex, this here. Again, because I'm now matching it to my master sketch, and up to vertex this here, the further one, because we're going to cut this at an angle. I don't want to merge result quite yet. I mean, I guess we could look at that. We could see. But like you'll notice, right, like look at what's going on here with this blend. I mean, here, I'll give you guys an example of maybe like what not to do. Let's just say we merge our result. It's very tempting to just go ahead and just be like, I'm just going to fill it the shit out of this and see what happens. Why is my Alt-B not working? It's really frustrating. Okay. I don't know, maybe this will work. Let's see. Again, in terms of best practice, like I would, that's actually pretty close. Okay. For this class, it's okay to use fillets in this way, right? Because this is kind of a more intro to solders class. Please, guys, for your design career, do not design with fillets. That is not good to do, okay? A fillet is supposed to be a finishing feature as much as possible, not a main feature. If I'm critical of that example file, let me save this. If I'm critical of my example file I did, sorry, Ned, I'm forgetting how to spell your name, E-N-A-D. Again, in an ideal world, this original file I built, that command I wanted you guys to look at, this fillet, this should probably be done with like a loft, ideally. Take all of these as rules of thumb and with grains of salt. Like, it is okay to, like, it's not necessarily wrong to use a fillet like this. It's also, here's where it's okay to use a fillet as a design feature. Sometimes it's easy to overthink something when a fillet will do. Like, where this fillet isn't good, again, if this is like going to production and stuff, is like, I don't know, it looks like there's a bit of a seam here. I don't know if you guys can kind of see that. It's like line right here. You can kind of see where the fillet starts and stops. It's very kind of clear. Whereas a loft would kind of blend that out a little bit better. It all depends on the amount of time and accuracy you're going for. Okay. This is pretty close. I don't know. I would recommend against it though, with this fillet. And now the reason why is like if I'm looking at this, like look, this is a lot tighter through here. This one looks pretty close. But like look at these lines, right? Honestly, these contour lines tell a lot of the story. Like that's a weird contour line. Look at how that jumps up like an S, kind of like that. So again, based on this object, firstly, I would not blend these. Keep an eye on time. I need to wrap this one up soon. I got 5 minutes. let's see, this ended up lower. That's interesting. Okay, what do I do here? Let's see. All right, well, firstly, I want to chop this angle. My hesitation now is that, okay, so this doesn't quite align, so I'm going to do a slight tweak here. Here, let's just see what this looks like. Again, I tend to do cuts like this with straight lines and doing through all in both and making sure the arrow is pointing the right direction, making sure you're cutting the right feature here. But what I'm hesitating about, honestly, this is going to be smoother if I just do it like this, is I don't like that this cut is happening in the middle of this circle. I want a nice clean face, a full circle to go to. So I'm going to just tweak the design slightly. Again, I think it's okay to do this. I want a line that's parallel to this one because I want it to be at the right angle. But I want it to go through this bottom corner here. And again, my reasoning for that is so that I have a nice clean round face to go to here. All right. Before I had that like awkward, you saw that at the bottom. So now essentially this object is two lofts. So what I'm going to do here, I'm going to split this object a couple ways. So on my front face, I'm going to split it horizontally like this. Again, splitting top and bottom. And then I'm also going to split using this line. And again, just kind of elongating it. This one I'm going to split front and back. Can I split on multiple objects? I can. Hopefully these don't merge though. I'm selectively choosing my splits so that they're not touching because I think they merge. I think SolidWorks wants to merge bodies. So you can see I picked front, back, front for what it's worth. Okay, that didn't work. That's not what I wanted to happen. If weird things like that are happening, it's because that it's splitting multiple different bodies. You can do it one split at a time. Yeah, you may have to. So then I'm going to do then a secondary split because you saw how those bodies disappeared. SolidWorks does weird things when you split multiple bodies. I think it just like merges stuff. Here you can say use the same trim tool. You don't have to make a brand new sketch. I'm going to grab this sketch again, and here I'm just going to split. Oops, not the face. Again, easy mistake to make. You want to make sure you're down here in this dialog and select this front. And so now, I'm looking at where these lofts start and stop. And that's what this is telling me, okay, from my master sketch. I'm going to make a sketch on this front face. And I'm going to pull a line here, perpendicular to these straight lines. Same here, perpendicular. I can actually copy this over. It's not necessary, I just need to connect them. But what I'm doing is I'm going to do an extrude cut now. Again, it's an open contour, so it's a thin cut. So again, I'm saying it's cutting through all and telling it to cut the inside away. And what I'm doing is I'm cutting these two inner bodies away. And that's so that now I have this space in here to blend this face to this face. You see that? So you're going to do the back the exact same way, but let's just focus on the front for now. So firstly, I'm going to pull this line because I want this to guide my loft. But now here's an instance where, and maybe I'm going to call everyone to pay attention at this point. I'm going to introduce 3D sketches, okay? So Anand is trying to loft from his handle to this main part of the drill. We have, let me just hide this. Well, no, maybe that's fine. I pulled this curve sketch to help with our loft, but it's going to be helpful to have part of the sketch here loft from this point to this point. A 3D sketch exists outside of a plane, okay? So it's not sitting on any 2D surface. It exists within 3D space. The 3D sketches exist, it's on a dropdown from the dialog here, so I can click on 3D sketch. This is, again, another instance for sure where I would use a spline because it's a little bit more complex and it kind of simplifies it for me. What I'm doing is I'm drawing a spline with no vertices in the middle, no anchor points, directly from one line to another. And then I'm going to select this line and this, and I'm going to say, I want you to be tangent. And again, I'm not going to drag or move this because this is giving me the smoothest tangent arc off of that. Do the exact same thing here and tell this to be tangent. And now you'll notice that it kind of juts out like this. And it gives us a nice kind of even arc through here and a nice kind of even blend. Again, I tend to advocate for not pushing and pulling on these unless you absolutely need to. The reason for that is you don't want to like pinch it too much or something. Again, it's not the be-all end-all. You could play with it if you wanted. To exit the 3D sketch, if you click on here, you can't. So if you forget this, it's frustrating. It's like, why can't I get out of this? You could always click on that there. But the way to get out of it is you would have to do the drop-down menu and select that. So basically, just introducing 3D sketches, that's a very simple way to use it, is to pick two surfaces that have straight lines, connect them with a spline, and make the spline tangent. It will make kind of a smooth curve through space. That's the only new thing I wanted to introduce. So if you guys are working, you're welcome to go back to work. But if you want to see how I apply this now, I select this face and this face in my loft. I can select that 3D sketch I just used. Now I could select this, but I want to make sure I don't accidentally select the master sketch. So I want to expand my tree and make sure I select this sketch here. And now you can see, look how smooth that loft is. You could add constraints and you could say normal to profile. Now let's see, why did that blow up? Let's say this also normal to profile. Oh, because this got twisted. You always want to make sure that these points, you want it to go correspondingly. So really this blue dot should be here, right? These are the top right corners. But this normal to profile seems to be goofing it up. If this is happening for you, like this loft, it means I need another guide curve. I need another guide curve. So it would be helpful to have another guide curve from here, this point to this point. It's not allowing me to select. I'm trying to select and drag these. That happens sometimes. I don't have a good answer for why it happens. You can also try reselecting the face, and sometimes that corrects it. Why is that jumping? That's really weird. I don't think so. Yeah, you can see like weird stuff that's going on right now. It's okay if that's happening. All right, I'm taking too long on this one. Again, I can connect these two. Again, I'm using another spline, and that's again because I'm not confident a single arc is going to blend these, and I want it to be with the smoothest transition possible. There's no vertices in the spline. I'm using this straight line in the spline and making them tangent. Again, I'm not pushing and pulling on this arm, making this tangent, not pushing and pulling on that arm, trusting that that's the smoothest arc through there. And now once again, if I loft this face to this face, and now I start to pull some of these guide curves, now that I have 3 defined, that's really all the corners that there are. I can now check this, and now that's a little bit smoother. Does that make sense? Now, unfortunately, I don't have time for this, but you would do the same on the back. You are going to be left with a gap in the middle here. And in fact, you can see how like, oh man, yeah, that's going to be a problem actually. let's see, you may need to, this is where surfacing in theory again would come in. You would go from, you see how this like necks in like that? And how this is wide and this is narrow? Here, if I show you a top view, it's going to be more obvious. You see that? That's the challenge. So you may need to, your loft may need to be actually, instead of going from this face to this face, it may need to go from this face to your top face. But essentially, if I roll it back before this loft, this is how I would start it. Same thing in the back, I would split this cut. Like for example, you may need to loft this to like this, yeah, to the top. Essentially, here, I'm going to show you surfacing very briefly. Surfacing is really similar. So I can, and again, if you guys want to pay attention now to something new. So surfacing, if you don't have this, you go to Tools. Where is it now? Customize, shortcut toolbars, toolbars, and you want to check surfacing, okay? Surfaces right here. I think it defaults to appear here. So, okay, if you guys just watched this demo, it was like lofting this face to this face. It was a 3D body. You can loft edge to edge. So this is a surface loft. So I could, here for profiles, I can pick this edge, and I can pick this edge. And again, provided I line this right, I can make these be tangent to each other. And now that gets me a nice loft this way. Now I can do another loft from, again, using surfacing to go from this edge to this edge. Well, ideally it would only be between these two. Man, there's not enough time for surfacing. The way you could do that, you can do that any number of ways, but for example, you could sketch a line that's exactly in between here. And you can loft from that line to this edge and use this as your guide curve. Okay, it's not working because of this point here. But again, you could use tangencies. Let's say this, honestly, this is tough because, and again, this is how you would go about it in an ideal world. Being kind of an intro to SOLIDWORKS class. Let's see, if you guys, I can get in depth into surfacing after I go through each of your files, if that's something you would like to see. But that's ideally how you would go about this, right? It's lofting edges to edges. And now do you see how we get, by using edges, we have a slightly more controlled loft going on. You can. Again, though, there's all this nuance to it because once you have all the faces, at some point you have to knit them together to get a solid body. So, okay, I'm going to have to conclude this for you. I'm already kind of 10 minutes over, but this is my advice to you, is to start it this way and try and split it out and try and figure out using lofts how to connect this. And not necessarily surface lofts. If you want to explore surface lofts, that's okay. Again, at the end of class today, I can do a brief intro on surfacing. It's like, again, it's more advanced. But if this doesn't work, if you go that fillet option, it will get you close. Again, just know that that's not the ideal way to build things. Does that make sense? So again, I would try and split it out this way, and I would try and figure out, I would try and just like play with these lofts. The first way that I built this with the solid body lofts, that may still work. Like, you just need to control, with your loft, you need to try and pull this body out further. Right? So the way you might do that is, with this 3D sketch, you might push this out. This is where you may want to pull this handle out further. But see, the problem is that it kicks backwards. Yeah. Oh, absolutely. Oh, the ruler. Yeah. Thank you. Okay. Any questions on any of that? I realize, like, again, my goal is to give you guys how to start, and then you guys fill in the gaps. It is a pretty complex object, and it is because of that loft going both in and out. Here's another way you could simplify it. If you made the handle, if you like brought this in a bit, right? So maybe the top is as wide as the handle. Again, not ideal, but that would simplify things for you. So basically meaning to say you take away this jump here, this left to right jump. If you align those, it'll make your life a little easier. So just get it as close as you can. And again, if you have to revert back to it, that's okay. Cool. All right. Josh, which one between these two?
This one's really similar, I think, to the demo we just did.
Yeah, it is similar.
So just with like a shell or like a street cut.
Yep.
Through here. I don't know if maybe there's something. I don't know. I just.
There's similarities in this one for sure.
Okay.
But it's a different object, so I'd approach it slightly differently, I guess.
Okay.
Honestly, it's whichever one you want to move forward with.
Okay.
This is definitely easier in CAD. This is harder in CAD. This is probably a little bit harder to render. But I can show you how to do this.
Yeah, because honestly, I wanted to get like a balance of both.
Okay.
I wanted this little like sexy render with the tasteful reveal, but also like it's like nice. This has a nicer functionality, I think, than this one.
Yeah.
So that's why I kind of just wanted to mirror it.
I mean, you could in your redesign, like, you could make this your main form, and in your redesign apply like some of these design elements to this.
Okay.
So do you want me to pick which one to demo, or which one would you prefer to see demoed?
Maybe since we already did. Oh, sorry. Just
rendering's next class.
Sorry. Okay.
I'm just showing you guys how to get started with this, right?
Oh, okay. You know what? Could you do
the loop? How to do this loop? Okay. But so this is okay. No, I'm happy to do that. I'm just trying to help you because next class you need to have this built. So if you end up choosing to do this, like, that's not going to be, basically, like, you should pick what you want to move forward with, not necessarily what you want to see demoed, I guess is a better way to phrase this.
Okay.
Okay, you think about it, I will come back to you.
Okay, sorry.
I mean, it's okay, like, I'm happy to demo that loop. You would do that with a suite. That's not going to be helpful to you if you're doing this, right?
Yeah.
And like, I at least want to give you guys the right starting position to go off of. Let's see, I don't have this image, Alexis. Do you know what I can search to get this by any chance? Nice. All right, very cool. Yeah, lots of good reference images. Nice. Okay, this one's pretty straightforward, thankfully. No, but it's still, there's complexities to it. There's like nuance. Lots of good images here of like how to go about this. Giving us good reference. Let me see if I can find this exact image that you have. Let's see, here we go. Now let's see it with all of these images if they have any. I don't see any orthographic views. I guess there's some. Oh yeah, there's plenty. So again, this is one way I would recommend you guys start, is grab as many of these views as you can, because it will make your life easier, especially in setup. What would be really nice is if they had a view of what it looks like from the top, like a straight top view, because then I'll know exactly the size. Oh, there's also dimensions too, which is nice. You think there's an exact top view on the bottom, towards the bottom? Okay, cool. Not that one, right? It's actually orthographic. There you go. Nice. No, this is perfect. This is exactly how you would want to go about this. So, all right. So actually the nice thing is that this one did give us dimensions on here. I think I saw it at some point. Yeah, here we go. Yeah, 85 millimeters by 150. So again, any place, if you find that, it will make your life easier. 85 by 150. And so now this gives us a reference point for when we import our photos. So now, by pulling this photo from my desktop, I can grab this image. Again, scale this way down to match. And then now from a top view, I can import the top view sketch. And then scale this to match. And honestly, that's probably all I need, I think, for this. The side view could be helpful for, but no, we have that in the top view. So really at this point, I could drag this sketch down. This becomes my front master, which actually, honestly, it's a little late now. I would probably have centered your lens on the origin, would be my advice. But I already have this set up this way, so I'm just going to run with it for now. Actually, what this doesn't tell me here, where the side view is helpful, is to know where the lens is located. Right? Does that make sense? Let me look at that sketch again, or that image again. Unfortunately, this isn't a full height. It only gives us the width. But it would give me this measurement of here to here. So here's what I would do. If you're, again, all for the name of accuracy. From this top view, I could make a slot shape on this sketch. That matches this point to this center arc. And same here. And now I can give this dimension and again, you just want to be close. Like you don't need to be, like it looks like I'm inboard a little bit. So maybe I need to get like a little bit wider. But the reasoning for giving that depth is now if I want to put in this side view image, oh, it's a GIF. So I would need to convert that. I can quickly do that conversion by just doing this. Now, something's interesting going on here is like this little, I'm not quite sure what's causing that. I'm assuming it's because the lens starts to interfere with the top of the slot shape. I mean, you have a very, it's a good object. It's made of primary shapes, but you have a good object to, it's kind of straightforward, right? It tells you what it wants to be, which is good. It makes your life a little easier, which is not a bad thing. Again, it's all an exercise in studying form and studying rendering. So again, I'm trying to pull in this side view. It couldn't pull in the GIF. So if that happens, you can quickly convert it by just taking a screen grab, scale this way down. Now here's what the reason I wanted this and the reason I put that slot shape in there is now I know how wide to make this on the bottom. And now I know if this is one edge of the camera here, I can align this all the way to the top and just kind of visually center it. And now I roughly know where my lens should be. Does that make sense? Okay. I think this is all pretty straightforward stuff. It's basically just saying like, hey, you can use these sketch photos or these photos as like, as multiple reference points to your build. So on your front master, this would again will tell you roughly where to put the lens. If I look at the side view, it kind of tells me how big the lens should be, right? So let's see how, you know, like maybe it would have maybe made more sense to put that side view on the front face so that I can actually see that, like aligned next to each other. Another way to do it would be to, before doing this sketch, to actually do a right plane sketch. And I can just quickly like pull these lines as reference points. And honestly, you know where this is also going to be helpful is when you add all these details into your. So like your overall form is pretty straightforward. The complexity of your form is on all these details that you're going to build in. But essentially, it's like a series of extrudes and extrude cuts and so on and so forth. But now that I have this side reference, now when I go to do my front sketch, I now have these points in space that I can kind of attach this to. So I can say, hey, I want you to be coincident. I can get rid of this dimension, and I can make this coincident down here. Now, hopefully, these renderings are accurate. They should be. It should steer you in the right direction. Let's see if we spin this around. Yeah, that looks pretty good. All right. I mean, so yours is a very basic level is just built with extrudes, but let's look at how we might approach some of these other things. Okay, so here's your top view. So ideally, in this instance, you do have a top master. Other things I put in your top master is like the size of the tray, if you're building that, which I guess I wouldn't. Let's see, if you're matching this rendering, I would. The trick with this rendering is going to be the lighting, having that glow coming up, but that can be done with an area light. So let's say we set up our master sketches. I mean, I guess I should demo this. So from this view, like other things I would put in the master are honestly like this port here maybe. You could like start to offset this to get some of these gaps. So again, what I would do is if you're selecting this whole slot shape, you can right click and say select chain and say offset, and maybe it's about 1 millimeter. There's a bit of a gap on the inside, offset also about 1 millimeter inside. The bigger tray I would probably do as its own. I wouldn't do it as an offset. I would do it as its own slot shape. But again, just basically aligning this. Now one thing I did do wrong here is that I offset wider here, and this first sketch did align up and down with this edge here. Bless you. And again, that's because I didn't quite align this top image fully to the edge of it, to this line truthfully, right? Like you can see this is a bit wider than where this line is. So okay, so if I were to correct that awareness of that mistake, instead of offsetting away 1 millimeter and inside 1 millimeter, one of them I'll offset always to the inside so that the farthest edge will always align. You still with me? I realize it's like I'm kind of jumping here. So like, or actually here, I'm just going to delete this. And I'm actually going to offset this one here. Okay. So that's just to simulate the master sketch. I think you get that. So okay, from the top view, at a very basic level, I want to extrude this slot shape all the way up to, again, I would do up to vertex and go up to here. Again, you could see this as like building half the sketch, so maybe when you copy that over, but let's see. For you, maybe it makes sense to build it all as one whole because the lens, it doesn't get mirrored, right? It's not like, you could build it in one half left to right, not front to back, is a possibility. Let's see, this lens, we know how tall it goes this way. Again, I would typically build the camera coming towards me just the way that I set these up. I didn't plan ahead quite well enough. Again, if you do have like a side master, this is again where you could tie it to it and have it go up to this vertex here. The question is whether I would merge these bodies. I don't know if I would yet, just quite yet. And now we can look at what this intersection looks like. Because on one of these images, you see that blend like that there. Let's see how severe we're getting this here from this side view. Kind of getting it. It's not quite as big as I anticipated. I don't know, nuance like that isn't, it is a little bit how it matches, yeah. Let's see, the bottom tray I would do as an extrusion. I would fillet the edge and then shell it. Then this light, I would probably just do that as a split. So it looks like there is, let's see, is it in our side view? No, it's not. It doesn't go quite that low. But it is, however, if I hide this, it is in this view. So again, in this like front master, I could have a line across here that tells me that I can align with this bottom line and the top. I'm looking at the light on the bottom, right? And I'm using these two horizontal lines to tell me where that arc goes. And from a side view now, after I've, again, this could be in a side master, it could be in after I sketch it, oops, on this right plane. I see these are the 2 points that I created. If I have 2 horizontal lines, that are centered or aligned on these points, coincident to this. essentially it's kind of like a split with an arc between these two lines. Here is where I'm not sure what I would do. I guess I probably would go tangent to this. Sometimes though, when a split is coincident like this, it doesn't want to work. Sometimes you need to add just like a little bit of line on either side, just so it fully cuts the body. What I mean is, if we ignore this down here, if I have a line that does this, hopefully this makes sense to all of you, that this would not split the body. Does that make sense? Because it doesn't go all the way through the body. So sometimes, in this instance, I'm trying to split it with the arc. Because it's coincident to the edge, sometimes you need to add these little ears on either side that make sure that it goes all the way through. So now here I'm going to use my split command. It defaults to that sketch I was just in. I'm going to select this. And now if I go to my bodies here and change this to, oops, not that one. Change this to transparency, we get a light that looks similar. Does that make sense? Do you have any specific questions? Yours is pretty straightforward. Again, I think the difficulty with yours is like getting all of these like extrude cuts and stuff. The Vertica is a 3D feature. What you can try and do, I don't is Vertica a real brand or is it made up? Okay. Here, let me just show you this because this will be maybe a new thing for you. I just created a sketch on this, and this is new to everyone. So again, if you guys maybe wanted to pay attention, now might be a good time. If you have any text that's three-dimensional, you can draw a line, make it for construction, and then there's this little sketch feature that says text. And I'm selected the line, and I've clicked that text feature. So now if I write Vertica on here, it puts it. Now you can change your font, right? It says use document font. If you uncheck this and click on font, I can try and, you know, whatever font you have on your computer, it should load it. That's terrible. And of course you can play with like within here, like the size. All right, I think you guys get this. But you can, once this text is done, you can extrude this just like any feature. If it's confused, you may have to select the contours. I think it's confused because of like the hole in the A, for example. I don't know why it's not. I promise this works. I don't know why it's not letting me select this. No. Here, let me try this. Sorry, this is. To edit it, you double click on it. Let's make it bigger and see if that helps us. I'll be honest, I don't know why it's not extruding. Oh, here we go. I believe this is causing us an issue. I don't know how to fix that. I will just pick a different font. There we go. Okay, now this looks hideous. Now let's try and see if that fixes our problem. There we go. Thank you, SolidWorks gods. You're not making me struggle too much with that. Okay. Cool. Does that make sense? Okay. Yeah, please. Yeah, absolutely. How to rename them or? Oh, if you click on, like not like a quick double click, but like select and then select again. You can type whatever you want. That works for any feature. You typically don't need to do that. Like what I'll do sometimes is I will, again, if I anticipate someone else working on the file, like I may say like where I start working on the lens, I may say like rename the feature lens start. Or sometimes whatever the last, so like you see all these like boss extrudes here. Like if I rename this as lens, if you look up here, it changes the body name to lens. So that's another issue or another instance where that's useful. Cool? All right. Did you make your decision?
Yes.
Okay, awesome. I like it. Okay. Let's see. Let me try and find this image. Who brought this one in? Okay. Do you know what I can search to find this or where you got this from? If not, no worries. Sure, actually, if you'd be willing to do that, I'd appreciate it. But I'll do a quick search too to see if I can find it. So what is this called? Inhaler. Nice, here's this one. I'll save this. Oh, is this Zarky from, it is.
Oh,
yeah, from Minimal. I'm not surprised. That's a dope render. He's really good at it.
Yeah,
He's super good at CAD, or yeah, rendering stuff.
His shoes are awesome.
Yeah, his shoes are crazy. I like some of his sci-fi stuff too.
Mm-hmm.
All right. I'm not finding it. Unless it's called, let's see, does this have a name on it? All it has is a number. Or you could email it to me, Josh, if that's easier. Or sorry, not Josh, Trevor. I'm sorry. Or Box, whatever is easiest for you. I'm wondering if it's one of these. It's just not feature. It's not like, but you know, it's not the leading image. I thought it might be, for some reason, this one, the graphic looked the same, but it's not. It must be this egg. Yeah, no, it's not. The other thing you're going to want for this one is you could try GrabCAD here.
Oh, for the albuterol?
For the albuterol, yeah. So you could if you wanted, but honestly, at this stage, it might be easier to, it's just a revolve, really.
Yeah, I was going to say. Just some arcs and...
So you, yeah. Okay. Try this. Lowest? Oh, low. How do you spell it? L-O. How do you spell Schwartz? S-C-H. Did I spell this right?
E-N-F-H.
Lois Schwartz does.
You sure to put yes? Oh, okay.
Oh, maybe I should Google it. My bad. Here, you want to just email me the image? I mean, it doesn't hurt. It helps, but
Oh, that is the name. Oh, it's one word. It's just camel case. Maybe that's why.
nope, not School of Law. Cheers, thanks. Let's see reports. Nope, I'm not trying to sign in. Thanks, Trevor. Appreciate it. Okay, so again, new file. Back in on this. So, okay, this one is, you're right, it is similar to the drill that we talked about for Ned. I am not as familiar with inhalers, but they're what, maybe 4 inches tall? No, not even, right? Is it about 4 inches? Okay.
I said that.
Hmm.
What's in the mouthpiece and then in the mouth there?
So yeah, this one looks like, you know what, actually you could totally do too. This one you could for sure get a side view of the butyrol.
Oh, what was it? One word? Huh. Oh,
No, it's all good. This, all right, this helps with understanding the form. It does look good in white. I do like that.
that's cool. You gave me the texture on that.
Yeah. Gotcha. Here's the image. Yeah, it is. So this, you want to put like a frost effect onto this image here for sure. Oh, the whole image is green, the noise on it? Yeah. A photo? Yeah. No, you're right though. Sometimes renders can look fake because they look so perfect. So adding imperfection to a render can make it look more real. All right. Let's see if we can find, did I spell albuterol correct?
That's what I had, the white one. Wait, that's right. That's actually pretty cool. I loved it, yeah. Because it was like transparent. So you could like see something, some part
Gotcha.
too opaque. That was kind of cool.
I was hoping I could find just,
It's a nice design, actually.
but here, let's just go with this. Okay. So we set this up all the same way. You get, this is all familiar to you guys now. Bringing in the photo. So this one, even though it's shown upside down, I don't know, my gut would be to build it the other way. So we would rotate this by 180 degrees. And again, look at like roughly how tall this is. Probably about 4 inches. That makes sense to me. So maybe it's about this big. And again, I advocate for taking this and changing the overall transparency, just knocking it down. All right. Now the same thing, now that we have that, we can drag our initial sketch for height and turn this into our master. Now, this is going to be, yes, very similar to the drill in that you're working with a couple lofts here. But man, this one's also going to be tricky, honestly. You guys got this, though. You can do it. So the albuterol should be relatively straightforward. It's just like the bottle, right? I would go ahead and I would see what's going on here. I would trace these. Again, it's up to you. I would maybe, if it were me, maybe leave that filleting. I don't know. You could do all the curves in here. You could do the filleting last, whatever it is you want to do. But does that make sense? This is pretty straightforward, right? And then you would revolve this as its own body. Now the main crux is getting this part of the body. And this is a little bit trickier because you do have this very beautiful split line through here, but this is two arcs. Making this tangent. Now again, it's going to be the same. We're on a very base level. Could probably fillet this, but wouldn't be ideal. And again, in an ideal world, you wouldn't be just filleting this. I did not intend for these to be symmetrical. Oh, it was lined with the line on the bottom. That's why I get it. So again, you're just kind of getting this close. This might be a spline with just how that curve is looking to me. But again, I do try and avoid them when you can. They're useful when you're trying to get a very smooth blend from 2 points, one to another, and you don't want like a bunch of arcs in between them.
You know, I think where it hits that line, I think that can't move on to this.
Yeah.
I think that's sort of, so it's not a.
Yeah. So
slight,
yeah, slightly chamfered. Okay, good observation. I agree with you. Let's see. Wait. We want this to be tangent but not perpendicular. So again, it's looking at these relationships. Oh, it's not. Okay, so we can kick this out a bit. I mean, if you really wanted, you could even just like dial in, whatever that is. Okay, rough representation of what your master sketch might look like. It's kind of like this split tree. Again, just like the drill, I would go insert, reference geometry, drop some planes in here on each of these. And again, the way that I like to do that is I select the line and then I select the point on the line and it exists on that point and it's perpendicular to the direction of the line. Now we have the lengths of each of these things. So, or the width of each of these circles, essentially. So on this first plane, I'm going to sketch a circle on here that's equal, the diameter is equal to the length of that line. On this, same thing. Sketch a circle that's diameter is equal to this. And again, this is at a very base level. On the top plane here, sketch a circle that's coincident to this. Now using this sketch, we're going to extrude. Now honestly, I could probably do this actually as a revolve to get the albuterol. But in this instance, for now, I might actually go up to this vertex. Again, because we're trying to get this lofted blend through here. And then same thing with this sketch. And here's where you may want to use this. You may want to draft outwards. Remember I set this to be 92 degrees, or like 92 and a half. That's one way that you can get this to get wider. Now again, I'm gonna be honest with you, that was a good observation and good nuance. For simplicity, for that build, it's so subtle that it will make your life easier to not worry about having it get that wide. Okay. Or you could always put that in later with how you approach your sketch. So I'm actually gonna dial this back into 90. Here's my reasoning for that, okay? You're starting your sketch perpendicular to this face here. If you have to guess how far that grows to try, basically we end up using this line as a guide curve for our loft in our master sketch. We are starting our sketch here. If it's getting wider, you have to try and guess how to hit this point. If it's not perpendicular, because our sketch exists on this line, on this face. It helps to have that be a perpendicular extrusion. And then you want to blend it with this line. If you have to grow that by guessing, like you may misalign it. The only way to do that, again, if you really wanted to, would be to dial this into a precise number and to extrude that circle at a draft that matches that number. Okay. Does that make sense? Yeah. Okay. So again, my advice is that observational nuance is good, but I think it's so subtle in this instance that it's the challenge that it's going to add to the complexity of this design. Honestly, I don't think it's worth it. So again, here I'm going up to this vertex here. So again, here is where this is where I would split these. I don't know if this is going to make things disappear. Thankfully it did not. But do you see this here? This is where I would loft. I would loft, and again, it may make sense to do this. Instead of extruding full circles, it might have made sense to extrude halves or quarters. So, okay, for example, I am going to use this front plane. I'm just going to cut away half of this. I'm using the front plane as a surface to cut. I've now split these bodies. Not only I've cut it in half, but I've also split it into a quarter. This simplifies the loft for us from here to here. And again, this is very similar to what we did with Inad's drill. But by splitting it into this quarter and making this loft like this, we now have part of this blend in here. And again, what I was harping on before was we could use this, again, if I go to my front sketch here, and pull this from the master, we could use this as a guide curve for our sketch. Now it's not happy with me. It's possible that, no, this should have missed that. There we go. I think the tangency is maybe not happy with me. Let's try this one. So once again, it may make sense here. I would probably do a guide curve on this back corner and a 3D guide curve on this inside. Okay. Again, very similar to the drill. But it wasn't happy with me adding that guide curve, and now it's completely jumping, which I don't know why that's happening. Again, weird things like that happening, if you take the time to put all those like guide curves in, that's going to prevent that from happening. Essentially, then you would do that for each of these other. So this one, you would loft this to the bottom quarter of this here. And then you would loft this to the bottom quarter of this one here. The same problem, though, is going to happen for you where you're going to have this triangle gap in the middle. For those of you doing complex lofts, if you do end up having a gap like that, I can, again, after I go over each of yours, I'll show you surfacing that can be surfaced over. Okay. If you guys get it close enough and there's a gap, next class is going to be heavy, right? Because we're going to be focusing on tee shot. So let's, again, after I go over Trevor's and Mari's, I'll show you guys a bit of surfacing. You can try and patch that up. Yeah, you would use a boundary. Yes, you could use a boundary fill. Yep. There's some basics to surfacing where you do have to knit it at the end. But I guess for the render, as long as you have that surface, you can apply a material to it. So again, like to your point, you would have a triangle in the middle here. You could use a boundary box to connect that triangle, and as long as they're tangent, you're going to get something that's going to be close. Okay. On a very base level, if you're frustrated and none of this is working, I think extruding and just like extruding all these cylinders into each other and just trying to carefully fill at them, it'll get you close. If you're really frustrated as a workaround. But best practice would be to do it as these quarter lofts and then blend it at the end with surfacing. Sure. Does that make sense? Yeah. Okay. Yeah. All right. Pretty cool. Yeah, we can totally do that. We can just scale and yeah, that's interesting. Okay. Okay. So because you know what it's called, and I think it's a real life product, you may be able to find actual orthographics of this. Maybe not. Yeah. Okay. Oh, this was a Kickstarter? Honestly, too, you could probably, if you find some Scotch tape lying around, that would give you some dimensions, because I'm going to guess that this circle is roughly the same dimension as this. Oh, great. Okay. So the way that I might start this, I would probably put, again, if this is your Scotch tape, I would put the origin at the center. So it's 3/4 inch wide by, what was the diameter did you get? It says, oh, okay. No, no worries. Yeah, at the end of the day, I mean, you are going to be judging by eye. I don't know. Let's say that this is 1.3 inches. Anyway. Oh no, we want the outside to be 1.3 inches. Wait, let's do that. We can just fix that by doing this. Okay. So that's going to represent our tape roll. This will represent the angle at which that secondary piece sits. It wouldn't hurt to have maybe like, you know what, honestly, no, never mind. I take that back. The way that I would build this is, there's actually a very simple way to build this. I would have that middle body represented here. So like this is what it would look like from a side view. And then when you render it, you would rotate it a little bit. So, I mean, I went about this kind of convoluted. I would obviously have made this with a rectangle tool. I think I'm currently on the front plane. So there's no right or wrong way about that. I mean, yeah, I think every designer is different. I think I just defaulted to the front plane and started to sketch the most obvious feature, which was the tape. But yes, if you wanted to be more like proper to the orientation of the object itself, to sketch on the right plane would make sense. For some designers, it drives them mad. Like, sometimes it will drive me mad if like if I'm working on a grill and the side of the grill is on the front plane, that drives me nuts. An object like this, it doesn't bother me as much. Everyone's different, but that's a good question to ask. Let's see where this meets. Okay, let me just show you on a very basic level one way to build this. You could almost take this main sketch of tape, copy it over, extrude it. Let's see, you said it was 3/4 of an inch wide. So it feels like my proportion's way off then, because I'm just gonna judge by eye here, just to get this. But that's a good way to start. I would for sure like your way of starting by looking at online reference of measurements. Let's go 0.4. Now you could, from a top view, extrude the same thing, right? And copy it over. Actually, you know what? Actually, no, we should go best practice. I was going to say that this could be done by a move body command and copy it, because they're probably the exact same size and proportion. But in terms of tweaking and nuance, it would be best practice. So like, again, if this is our side view, we're saying like, what did I end up deciding? That this is 0.4 tall. And then again, if this is, here's another kind of thing we can do. If we put in a center line here for construction, we can tell these two lines to be equal. And now, as this diameter changes, this length will change so that they match. But now if I'm studying this, it looks like this does not meet exactly in the center. I'm breaking this relationship here with a trim on the center line. I still want this to be coincident to the origin. I'm just trying to get it off center. Whoops. I'm judging the tape from a side view. It's a loop within a loop. The tangent edge of that loop on the inside, I don't think matches to the center of the tape. It's slightly off center. Right, I'm drawing the side view. Does that make sense? And again, it's all about trying to set this up like in as clean a way as you can. So now again, here, now that I've broken that relationship, I want these to be equal in length. But now this is blue, so I can like kind of drag this in. And this is probably something that you're going to want to change here. But this is equal to. So before I do that extrusion, it may not hurt from this top view to get this extrusion in here. Or sorry, to get this sort of, what's it called? Like a top master, essentially. And now that we have all these reference points, I can now make all of this coincident. this may work. Let's see if it does. Can I make this equal to this? No, I cannot. Okay. Because they're on two different planes, I'm pretty sure that's why. Ideally, though, now what I could do, actually, if I wanted something like that, is in this sketch, if I draw a line here between these two, I now have a length reference that's in the same orientation as this sketch. So I could have a line from here to here, set this as for construction, and set these to be equal in length. And now this circle is 100% driven by this other circle. Do you see that? How those relationships play off each other? Okay. And now here, same thing. I can say, or sorry, I can let the vertices on this shape also define how tall this is. Make sense? Basically, they're both extrudes. I just showed you how to set up the two sketches so that they relate to each other. So that now whenever I go into this sketch and it turns out that actually this is like, I don't know, 2 inches in diameter, and maybe this grows too, that the other one also changes. Make sense? The rest of the stuff you would just do with kind of like extrude cuts and details. But basically what I'm looking for is like, you should have a slight step to the inner spool of the tape, right? So if we look at this, and it's better shut on the computer since I'm recording this. Like, you know, yeah, like I would have this white line right here. It's like incredibly nuanced. I would have this edge like step out of the tape slightly. Ever so slightly. And then like obviously you have an extrude cut in here, you have an extruded face on here. This is done with an extrude cut, this is done with an extrusion. The teeth can be done, here let me show you quickly how to do some teeth. I like my first proportion better, so I'm going to just go back to that. What was it? It was just double. Whatever, let's say it's 1.5. Again, I like what you said about looking up tape dimensions, just shows right. Okay, so if we're doing teeth on here, I'm just going to kind of roughly, very inaccurately get you close to what it might look like. Protrude slightly. The height of this is maybe I don't know, a little bit more than a millimeter. Don't merge the result because you only want to cut this thing. All right, so this is where the teeth might be. Let's see, I guess we could sketch it onto this face. Instead of taking the time, you could take the time to sketch all those V's. It would take a long time. So one workaround, and again, so if anyone wants to pay attention now, here's a new feature for you guys. So Mari has to do a bunch of teeth on this front edge. She can do it by just doing one cut through all here, selecting the body she wants to cut. She can now take this feature and have a curve-driven pattern. So again, this is a new feature I'm teaching you guys right here. It's basically different types of patterns you might want to do. So again, in this instance, she's picking curve-driven pattern. Because I was already selecting the feature in the tree, it's checked in here and it's down here. What you do is you want to select the curve or the direction that this travels within. And here you want to set what the spacing is. So in this instance, right, if she dials in 0.1, you can see those teeth apply. Now, I'll be honest, I'm not quite sure why it's bending in further. There is a workaround for that I can show you guys. But obviously you want those teeth to be really close together. You just type in a very small value in spacing. Right, eventually, whatever, you can dial in a number that makes sense, maybe like 0.03. And then obviously this is the number of instances that you have. Let's see, we're probably going to get an error. No, we didn't. Okay. Something weird's happening where the curve, for some reason, oh, you know what? It's maybe the way that I had the sketch. Because it's kind of sloppy. But anyway, does that make sense? You want to just control this a little bit better than I did. You can see like it starts wide and then it gets narrow. I'll be honest, I think it's because the sketch is just like a little bit wonky. Yeah, it's pretty. Okay. I think if you had like tangent to this edge and had it like symmetrical about its center, it should work better. Cool? Yep. Okay. I wouldn't go that far, I'll be honest with you. Like, let me say this. A curve-driven pattern, yeah, I'll be honest, I think that's what the issue is. I think what happened there is that I'm going a little quick. But sometimes weird stuff happens. Like the curve maybe is not quite, the alignment of the initial cut to the curve is not quite right. We had this conversation before about patterning features versus bodies, I think. It's always, in some respect, in this instance, it's okay because it's teeth and it's a relatively simple procedure just to cut. So in this instance, it's okay. If you are trying to be like best practice and proper, patterning features in general is not robust, and it does lead to some of these things like we saw. It is possible, you know, if you want to be nuanced here, it is possible instead of to do a curve-driven pattern. Again, if you, just like we had this discussion, I think last class, it is possible to take this sketch, and you'll notice there's a very similar icon here, and you can I guess there's no curve-driven, there's no curve, I thought there was. To do a pattern within a sketch driven by a spline. Anyway, in this instance, we do have this is part of a circle, right? So we could, in theory, now that I have this circle in here, I'm pretty sure you can do a sketch pattern along a spline. I would have to look at it. I think it's a feature that has to be like, it's hidden. It's like within SOLIDWORKS, but it's not a default. I could do a circular sketch pattern. And what I could do now is it's asking me what the center of the point that I'm rotating about. I want to select this here. And now I can actually pattern these teeth. And maybe I don't want to, you know, for example, I don't want to pattern it the whole way. Right, I'm changing the settings. So it defaulted to 360. And I'm saying, you know, this is about 90 degrees here. I can change, let's see, what is it that I want to change here? So the default is equal spacing within 90 degrees. And how many instances do I want? So the more instances that I put in here, the more teeth I'll get. The issue that's going to happen is my sketch is going to start to crash into itself. But this, if you're talking about robustness, this is a little bit more work, right, than the other way, which is why I showed the other way first. But in theory, it's going to give me an error because of all these intersections within the sketch. But I could, I'll delete this. If I edit this sketch, the reason I want to be in the edit is when I go to do the extrude cut, I want to be able to select the contours that I want. And so in this instance, I could just come in here and select all of these contours. Again, it's more work because it's like selecting all of these. But in theory, like you can see now, there's no error that we had before. It's actually following truthfully this gap and maintaining that. So that was a good question to ask. Again, there's multiple ways to go about the same goal. In general, patterning features or mirroring features is a little bit less robust than doing it as a full body or within the sketch very long answer to your question, but does that make sense? So yes, I mean, like, do you see how much cleaner that is? Obviously, there's a misgap here. Well, actually, no, let's look at this. No, you know what? This is what it is. It is, yeah, it's getting more narrow. It's a little bit cleaner. Yes, I was going to say, I think that's what it is that this is not symmetric about the center. Yes, that's even more so what it is. You're absolutely right. So like this line here, if we want to fix this problem, I mean, let's see, we want to make these collinear to each other. And then we want to set this to be for construction and set this to be symmetric about each other. And now it's not happy with me. I mean, yeah, it's a very long way to say that the gist of this is that I was a little bit sloppy in how I set this up. I think so. They kind of, it looks like they snap too. Oh, sorry, just jagged. I made it perpendicular. Yeah, not only did I have it point to the center, I think it's still not perfect. Let's try that symmetry again. And you know what? This is throwing me off too. I don't know. I'm going to make these coincident and see what happens if that fixes anything. And again, let's see if I can make this. I can make these symmetric. Oh, they are. They're already symmetric. You know what? That might have been it. They weren't pointing to the center. It still wasn't pointing to the center. There we go. That was it. All right, deep dive on food. Yeah, okay. No, seriously though, sometimes that is SolidWorks, is like figuring out geometric relationships and little things like that. Like that line wasn't quite pointing to the center. So now as it rotates, it slightly gets off more and more or something, and then it gets like skinnier. So sometimes you run into these weird, like, what is going on geometrically and how can I fix that? Sure. Right. No, that was a good, I mean, that was good. That's totally, again, that goes on all the time. Yeah. Okay, cool. I think I saw that and I think I downloaded them. It's going to be tough. Oh, wow. All right. Believe it or not, I think not as bad as, or not as challenging as some of the others, but definitely challenging. So there's this one and then there's this one here too. Holy smokes. Okay. All right, let's talk through this. This part of the object would probably start with a very basic extrude with a fillet. I think that's obvious maybe. But now the question is this kicking in? It looks like it is. Yeah, a lot of this is surfacing, I think. It looks to me like there's a slight kick and bend within here. There definitely is. Alrighty. Right. I mean, I wish this would be, I mean, I guess these are somewhat orthographic in nature. Mm-hmm. And what do you intend to transform this into? Okay. And now it would help to, okay, I guess you're specifically picking this one here. All right. I was going to say it would help to pick a render to match. All right, if I try and simplify this, okay. Essentially you have, again, this is probably the simplest part of the file, this bend with the microphone, and then this part with the ear. This is going to be incredibly hard to set up because it's very organic and it has all these different facets and angles, but you're going to have to do the best from judging from these two views. These are good photos. These are good reference photos. But essentially what you have here is you have kind of this bend. This, I would say, is relatively simple. Again, if I ignore this whole top piece and just look at this bottom, this is a slot extrusion that has a fillet on one side. Pretty simple there. It does bend. This is essentially a revolve. This revolve, but then you're kind of lofting into this mass in the middle here, okay? You may be able to get away, again, if we're oversimplifying, to properly build this whole center is going to be surfaced, okay? And again, I'm hoping there's a little bit of time at the end to give you guys some basics on surfacing. It wasn't something I was intending to get into. Again, my hope was that most things were buildable by lofts and sweeps and everyone picking to their own ability. Now that said, I mean, I'm very glad you guys are challenging yourself. And I do think that this could be done. You may be able to do this with solid body lofts and with lots and lots of guide curves. I think for the sake of time, instead of like showing you how I would set all of this up, I will show you the more complex part of how I might approach the center, okay? As opposed to like setting this all up from scratch. It would be very similar though to all the other stuff I've done. I would probably take this view right here, and this is probably your top view maybe, and you could have this contour sketch. I would probably sketch, this is what I would call a bent slot shape. I would extrude that. I would then cut it at an angle to get this to be sheer, like, because again, it bends. That cut would probably come perpendicular to this line. Again, very kind of complex. I don't know though, maybe this is the best way to start it. Sure. Okay, here, I'll just jump right in. This is where my gut is again on this top view. So I don't know how long these ear pieces are. I would probably say that I would center the earpiece about this origin. I would say that what is that, maybe half an inch, 3/4 of an inch? Let's go 0.4 for the earpiece. Make sure we're in inches. The jaw part is probably like what, inch and 1.75 inches long. Maybe let's just call it 2. Not 12. Yeah, guys, at this point, I'm sorry, we're probably going to go right up to full class time today, 6:40. Because like I said, at the end, I do have grades to hand back, and I do want to show you the very, very, very basics of surfacing. Okay, so this is how I would start this. Again, just like everything else, bring in this photo. We're going to use this main view here. See, but this isn't true either though, because this is kicking in at an angle. all of these varying angles is what's going to make this incredibly difficult. But we're just going to arrange this roughly like this. Here we go. I don't know, maybe I do need to spend more time showing you how I would set this up. I'll go over the basics, and if you have time after class, I can go give you more nuance on how to set this up. All right, we're just getting this roughly aligns. Same thing, rearrange this sketch. So again, I'm just giving us a starting point for where this loft is going to happen. Again, I would take these slots, I would take more time to align them, I would extrude that and do a cut from an orientation going perpendicular to this, so going this way, to get that angle. But again, for now, I'm just going to pull this slot to begin with. So again, imagine that I'm extruding this whole bent piece. Again, I'm just pulling this portion of the slot for now. Also in our top master is where we would have this shape. It's not a pure circle. Let's see how close it is to one. And I'm guessing this is due to the ergonomics of like the ear. Let's see, what would my advice be here? This is tricky. This may be a trace with splines kind of situation. Because I don't even think this is symmetric left to right. Like this is completely its own form. In terms of matching the render though, if you wanted to do a circle, that is fine by me. It's close enough, I think. And I think there's enough complexity going on anyway. And that may simplify that blend a little bit. So, okay, let's see, same thing. Well, firstly, I extruded this too tall. I think just proportionally, this is not quite as big as this. I guess not that it matters for this. I would approach this the exact same way as all of our other lofts. So, meaning to say, just going to pull this. I would split the body and do the loft in pieces, and that will make it more clean. And again, think about this as like kind of again, a deeper dive into what we already learned before, like more nuanced. So I would split this along this line here. So using the split commands here and here. Again, sometimes it helps to pick opposites so they don't actually merge. And actually the way that I would have done this, here I'm using a bit of an offset. I can do this with a cut, but I'm just trying to leave a bit of a gap. so that now I have room for the loft to exist with it. Does that make sense? Now, essentially, if I'm looking at this, let's go back to this view here. All right, it's going from the top. So oh man.
So why don't you start off with this slot instead of cylinder?
Like the earpiece?
So
see, for me, this is a flat with a fillet running around the edge. The reason I'm starting here is I think this is the most complex part, and I wanted to show you how to do that. Again, like this could be, honestly, this could be overthought. It is a bit of a cop-out to do this as a fillet, but you could, honestly. You could do that too. You could start with a sweep, I guess. I would do this, again, this shape I would do as an extrusion. I would then cut it at this angle, and then I would fillet this bottom portion. The more that I look at this, again, it's a bit of a cop-out, but you may be able to just blend an extruded circle to this angle and fillet it out. I mean, I think part of the challenge here, again, and it's really hard to get from this, but it's to get all of these angles and which angles they're going at. I'm just going to continue my line of thought here for a minute. Is if we're just focusing on like what this loft, I mean, again, this would be an instance where you may want to surface loft this. So for example, and again, this is when we get into surfacing, you get, pull this center line. You want to use things like split lines, right? So surfacing, it's like there's all of these new features. Not only are there surface features, there's also these, I believe these are called curve features. A split line is what adds a tangent, like adds a feature line or a tangent line in the middle of a face. So now we've split this face into two. So this loft can be done from this edge to this edge. And we can start it with a tangency to this face, but pointing down. And that gives us part of what this loft might look like, okay? In theory, what we would do then is we would walk all the way around. We would then do the same thing from here to a quarter of here. This is where it gets tricky because we would probably put another split line here and do a line from here to an edge here. Another way to do this, and which is how I was initially setting this up, and again, if I do this by just, honestly, actually, maybe chopping it with this, let's try that. I want to cut the outside of this, right? So again, this will be, hopefully I didn't get rid of, yeah, I didn't, thank goodness. Again, this represents being merged into that other part of the noodle, and then with a fillet on the bottom. But on a base level, again, with what we've learned in class so far, you could get away with a loft similar to this. All right, with a little bit, again, with more control curves through here. So I would have a control curve from this corner to this corner. It probably would be beneficial to fillet this, which even though may seem weird at first, when you blend it into that noodle, it'll disappear. The reason we're filleting this again, the way that lofts like to work, they want to go, do you see how this has two corners? You want to go from two corners to two corners. You don't want to go from three corners to two corners. Does that make sense? So that's why I'm filleting this edge here. So again, in this orientation, nope, that's right, this is not on a clean surface or clean face. So I'm going to sketch on here. Again, I'm just making guide curves for my loft. The more guide curves you have, the more successful your loft will be. There is a chance that if this gets too narrow, if it gets too acute, that fails. It'll hurt the loft, but we'll just see if this works. I'm doing 2 independent sketches. You could do it in the same sketch, but let's see, this looks like a straight blend. This would be another instance where you could, if you wanted, take away some of this guesswork by just doing it with a spline. And again, the way that I like to use splines is not with any vertices in the middle. This looks like this. Oh, of course, this is a straight cut. This one I'm going to do with a straight line. The reason why it's a straight cut is, again, I forgot because I used the profile of this circle to get this sketch, and that's how I got this here. Okay, so now we have 2 guide curves. Let me hide this reference image. I can now, again, loft this face to this face, and now we can try and use these guide curves. That might be too acute. Seems to be working. Let's try this. Where it's not merged for now. That's pretty close to like how you might want to start this, or at least do that complex area. You would then do the exact same thing on this other side. And now again, when you do build out this noodle, this is incredibly rough, but I'm just going to run with it. I always kind of like pull these out longer, trim this. Whoops, I went the wrong way. Let's go down. You know what? No, I don't want to merge this quite yet. Again, this is the way that I see the noodle, as having a big fillet on this face here. But this loft may get you close enough, and this is kind of tucked away, that once you get those fillets in there and you do get this merged, so again, there's a combine feature. I guess this is a new feature, guys. So if you're working independently, trying to work on individual objects, at the time when you're ready to combine them, you can select all of the bodies here. It's called combine. You can join them. You can then fill it out like this last blend in here, since it's like at the bottom. It's kind of hidden. Does that make sense? That's probably the most complex area, and again, that's how to approach it. I would just treat it as a very simple loft, or try and treat it as a loft by doing it in halves. Does that make sense? The other hard thing, other than that area, figuring out that area, let's look back at this. So you'd probably have a similar loft on this other side. I think, again, that will get you close enough. Now, what the challenge is, I'm making an assumption here that these two are facing the same way. It actually, the more I study this, okay, I started to say a sentence. The other challenge is just getting all the orientation of all these things correct. They're all pointing slightly different directions. So it looks like this noodle is at a slight angle to this sort of disc. Meaning to say, like this, right now I have this and this to be parallel to each other. I don't think they're parallel. I think they have an angle relationship. The good news is the loft should still work even at an angle relationship. The way that I would set that part up, and I'm not going to get too far into this, Um, if we use this disk as our central point, so that's kind of like our 0 point. This can be our up-down vertical. So again, let's ignore all this loft and stuff for now. I'm going to actually just roll back my tree to here. This is our 0 point. So we actually have this noodle going off at an angle. You probably want like a master sketch that gets all of these angles. So this represents the main body in the center that I'm representing with a disk currently. And again, this is complex enough that I'm okay if you want to treat that as a disk, that's fine. The noodle, it comes off to the side here, but it also kicks at like a slight angle. So that means from this orientation, it probably kicks, you probably want to extrude it like going on a plane going this way, because it's at a slight angle. Does that make sense? Like I could probably draw this better, so I'm sorry it's going to go away from the recording. But the way that you might want to start, your master sketch. And again, because you don't have a physical object, just do your best to guess. You can see the way that I started my master sketch was with the overall 3D shape. However, these are all going at different angles. The way that I interpret this is that there are 3 major angles, but the problem is that they have very complex relationships to each other. So again, the starting point is you have your main circle shape. And if we call it, this is the 0 orientation, this is y here, right? This is the y-axis. Your noodle is like at a slight angle here, right? So you want to project whatever this angle is perpendicular to this to get this noodle at that angle. So you have the 3 things are referring to as a noodle as a speaker. You have the main body, and then you have an earpiece, which is going off at a different angle. So essentially, like, if this is your y-axis, you have to figure out, if this is your origin, you have to figure out the angle that the jaw piece is going off at, and the angle at which the earpiece is going off at. But then from the top view, they also have like a more complex relationship of like how it's kicking, right? I don't know if this is the best I can do with this. Does that make sense? Like, if we take, if I adjust this one at a time, if we look at this jaw piece, and I draw what it looks like from this orientation, that main central body is a straight line because that's our 0 point, that's our origin. And again, I'm saying that jaw piece is at an angle, something like that. So step 1 is to figure out what that is. And again, that's our relationship of the y-axis to this angle. I would make a plane that exists on this face to get at that jaw piece. The next thing is to figure out, and again, that's going to be looking at it from this point of view. Now, if we look at it from this point of view, it means that this is kicking off at maybe a 45-degree angle. So that means let's see. That means that the earpiece, this is the jaw. The earpiece is opposite. It's coming off this way. But not only is it kicking at this angle, from the top view, you can see that it's like kicking also at a 45 left, right. So it's like a 45-degree angle kicking down and forwards, essentially. So your 3D model would start with all of these straight lines, essentially building up a tree and putting planes at the end of those trees, and that's how you would start those trees in deployment like I showed you, by breaking it down. So you would have a plane for this that either in the plane could either be an extrusion like going this way, or it could be a plane this way to get that revolve. This again, I would try and get a plane that matches where the Jabra silver is and extrude that. I would then have this be your main plane, your top face, and extrude that as a disc. I would then try and get these blends and swaps. So what I show you by splitting this in half, splitting and then splitting this in half, flopping there. Here the same thing. This is going to be a little bit easier. This is probably going to be a lot from the earpiece to the whole disc itself. And that in this instance, you should be walking from a circle to a circle. It'll get you close. It's not going to be exact. It's a very complex object. In order to build this, like exactly, you would probably need to order and like, literally look at what's going on. Because it's kind of hard to see what's going on here. Basically, what I'm trying to do for you is simplify it into this circle to a slot, circle to a circle. Cool. Okay. Yeah. No, I mean, either way, honestly, in this day and age, this would probably be sketched up first. They probably have, on it, because this is an earpiece, there's probably like a lot of nuance to the inner ear and how this works. So they probably have a template to start with that gets them that form. But yeah, in the past, more likely it'd probably be done in clay. Every place is different. Some places may do it in clay, but honestly, this would probably be catted up, 3D printed, and tested. And again, the reason that I bring up that they probably have the familiarity with the like inner shape of like what's comfortable, what's not. If you're exploring that, you may start with clay, yeah, and see how that feels. Any rapid prototyping. But I would assume, again, more often than not, it'd probably be catted up. Cool. That was a very deep dive into this Jabra. We had the no problem. Okay. All right. So guys, your homework is to build each of these for next class, okay? So, yeah. And really, this project is heavier than the other ones. It can be, especially with some of these ones you guys have picked, which is great. I'm glad to see that. This is basically saying just stay on top of it, right? Don't, if you come into next class without these built, you're going to significantly set yourself back. Because if you think about it, not only do you have to have this built for next class, we're going to talk about rendering this next class to match. You then need to have a plan on how to transform it, apply some of the design details we talked about, such as like buttons, whether to keep it flush. And essentially you're doing between next week's class and the following class when project 3 is due. Let me double check that, but I'm pretty sure it's due 2 weeks from today. Just before spring break, yeah. That means that hopefully next class you leave with like the first component done, where you have the object built and you have the render match. In theory, it should be relatively simple to complete the project because you should be able to transform it just a bit. Or not just a bit, but like enough to make it something new, add some details to it. But ideally, you already have the object. If you set it up well with a good master sketch, transforming it shouldn't be too hard. You already have the render set up. You can just re-import it. So you have, hopefully you have like the heavy lifting done. It's more about transforming it at that point in time. Okay, but again, just to emphasize, please have that done for next class. I know you guys are all tired. I'm sorry that it's like class went this long today. Again, I was hoping that by like trying to attempt to build a lot of different objects, you at least get a sense of maybe how to differently use sweeps and lofts. As promised, I do want to show a bit of surfacing, and I'm going to keep this as incredibly short as I can. Yes, please, if you guys need more brain food, help yourselves. Okay, you know what? I think I'm going to use it. I'm going to show this on Josh's file. I don't know. All right. So let me just complete some of this stuff. Yeah, that works. That works. Okay. Sorry, it requires a little bit of setup to try and get this to go. I'm repeating this again. This is like a really simple, if you guys need to cut something in half, you can select the front plane or the plane you want to cut with. This is kind of a new command. It's called surface cut, cut with a surface. You're using the plane as a surface. You look at where the arrow goes and it blows everything away that's on the opposite side. All right. So I'm just gonna loft here to here. Hopefully these play nice. I'm not gonna worry too much about guide curves. Again, guide curves typically help, always help, but for now, also for now, we're not going to merge. That's what my gut is telling me to do. And then this here, we're gonna loft this to this. Again, hopefully none of this is new. It's all just solid body lofting faces to faces. We're gonna go normal to profile and this normal to profile. And again, no merge. Okay. So this is the crux. I showed you guys how to start a lot of your files. The challenge here, oh wait, I went to the wrong face here. Well, that's fine actually. Let's leave it. Honestly, the challenge, like that's really only half the battle is getting set up. The other half is completing this. So you may run into instances that look like this, okay? Surfacing, it's building with just the, again, if you want to think about this as a piece of paper, it's building with just pieces of paper as opposed to a solid piece of foam is the best analogy I can come up with. One of the challenges with surfacing is like once you enter surface world, you kind of have to work. It's not enough. I could surface out this hole right here, but then I'm left with a surface and three bodies touching it, okay? You kind of want to enter completely into surfacing. One very quick and easy way to do that is by just straight up deleting faces. And again, this is a surface tool. It's called delete face. If I'm trying to fill this gap, I can delete out all these faces. And what that's going to do, it's going to change my solid bodies here now into three surface bodies, okay? And you can see that the face is actually missing and these look like pieces of paper. Now there's different tools to use with surfacing. There's the loft tool, like I showed you guys. What did you said? Boundary surface? Boundary fill. There's filled surface, which I would, now for this sake, I'm probably going to just use for simplicity. This is not planned out well, as you guys can tell. But there's a chance this won't work. But filled surface is a very simple way to basically be like, hey, I have a hole. I want it to be blended away, okay? So in this instance, there's this triangle gap. You're going to have something similar to this with your file. What I did is I selected all the edges. You'll notice that if I forget an edge here, oh no, this is all, but sorry, let me forget this edge. You can see it doesn't turn yellow because there's a gap. But if you select all of a closed contour, it'll fill in this yellow here. Now these edges, you'll notice they all say contact. This may fail, but ideally we want this to be tangent because we want it to be smooth. Yeah, do you see that? That's always fun things like this happen. You can always see like how many you can get to be tangent. This is really just, again, this is a very like patch simple. The problem is like without it being tangent and without planning this properly, you kind of get wonky things going on like this. Now there are, again, let me show you like one way to fix what's going on here. And then I'll wrap this up and give you guys back your grades. Sorry today was long, but I appreciate all of yours attention. So this loft gave me this curve, okay? So on this front face, I'm pulling this sketch from this curve. Now, you know what? I'm forcing a lot to happen within here, within this triangle. So here's another way that I could approach this. I could say, I could do this maybe as like, where did that go? I could delete this away. And I could do this as a loft from here to here. So selecting those two edges, right-clicking and selecting Selection Manager allows you to select multiple edges. Okay, this doesn't want to go tangent because it goes to a point. Okay, I'm going to go back to this just again for its sake. What I was going to show you guys is another way to do this is to limit the tangency. So instead of having it fight between the three, like, or here, maybe, let me do this. Let me see if this works. Like sometimes when there's more space in here for it to work, like this surface fill should still work in all of this here. It's just not quite as clean because of it's now covering a larger gap. But what this affords us is now we could there should be more room for these tangencies to work. It's not as constrained, so it allows there to be more room essentially for the blend to happen. The issue, I believe, is being caused because it's coming to this point. So anytime you're trying to like blend something, if you give it a little more room to breathe, that blend will work. So how I would fix that again, if I had more time here, is instead of trimming this right down the center, I might actually trim this to here and trim this to here and leave about a 1/4 inch gap. That's going to allow more room for that tangency to work. For now, I'm just going to kill this tangency. I mean, I'm kind of doing that right now by showing you guys that by making this blend happen across all of this space, as opposed to constraining that triangle, it can get filled. The last thing I want to show you guys, so basically, you can delete faces, you can use surface fill to kind of blend things away, you can use a loft. A more constrained loft is boundary surface, where essentially it's a loft in two directions. So the way that boundary surface works is if you have a surface like this, you can loft this way, boundary surface loft will be one between the two. The boundary surface edge here is you can loft whatever is the four-way loft. It lofts this way, or two-way loft. It lofts this way and it lofts this way. It's four-way is four-way. That's what boundary surface does. To complete this though, essentially all you do, so again, you got loft, you got boundary surface, you have fill surface. Fill surface is the most simple, and this is total crash course in surfacing, I realize, and we can get more in depth into this. But whatever you do to the outside, you want to also fill on your inside, and now you should see that I have an object that is completely constrained by surfaces. It's just like a sketch when you extrude a closed contour. You don't want to have overlapping lines because you'll have an error. You don't want to have overlapping surfaces. The last thing you want to do to make this a body is use this command called knit. It always looks like a vest to me. But you select all of these surfaces. Hopefully you're not missing any. You check create solid. You hope the SolidWorks gods are with you, and they're not. But you click check, and it should form a solid body. I think what's going on right now is that I think the point is what's causing issues here. Again, guys, do the best you can. I'll be honest, these are great selections. You know, more power to you. Do the best you can. If you need to use filleting as a form of modeling, know that that's not best practice, but for an intro to SolidWorks class and for simplicity, if you need to do it, it's okay. Just try and break it down into steps. There is a lot of trial and error. For those of you that pick these complex objects, be prepared to try a loft, save a copy, try another loft, save a copy, try another loft, save a copy. If you have to revert to fillets, try and organize the way that your fillets go. Meaning to say, like, if you try to rearrange the orientation of your fillets, it will change how the overall thing looks. Cool? Any questions on anything? I know it was a long class. Thanks for your attention.